Hi, this is Juan from JuanTutors.com. Welcome to my totally free office hours. Today we're working on the August 2016 New York Geometry Common Core Regents exam, problem number 11. If you want to access these exams, go to nysedregents.org and click on the appropriate tabs. So here's the problem. Segment CD is the perpendicular bisector of AB at E. Which pair of segments does not have to be congruent? ADBD, ACBC, AEBE, and DECE. Now, what I recommend is to try this problem on your own. Pause the video, see if you get the same answer as we do. Definitely, if you do get the same answer, click that like button. So I've seen a lot. This is my advice. If you want to take this advice and then pause the video. Here's what I see a lot of students do. They try to do this problem and they're like, I don't know, and then they try to guess at somehow, but without a diagram. How are you supposed to internalize all this information without drawing a diagram? My advice is draw a diagram. So try to pause the video now and see if you get the same answer as we do, after you draw a diagram though. So CD is the perpendicular bisector of AB at E. So here's AB. I'm going to draw it horizontally. A, B. And CD is the perpendicular bisector, so it's going to go through this point. Okay. Good. And this is CD, and this is a right angle, and this is point E. Okay. So, which pair of segments does not have to be congruent? I'm going to label the fact that it's a perpendicular bisector implies that AE is congruent to EB, and we're looking for does not have to be congruent. Hopefully AE and EB are a choice. AE and BE, AEB. Oh, look at the number 3. AE and BE have to be congruent because CD is the perpendicular bisector. So that's not the answer. So let's look for the other ones. AD, BD. Okay, so let's draw AD, BD. AD and BD. Okay, so now why would these have to be or have to not be congruent? Well, if you notice that DEC is the perpendicular bisector of AB, which means that as a part of triangle ADB, DE is both an altitude and a median. So as a result, this triangle is in fact an isosceles triangle, so that this side is congruent to this side. So AD is in fact congruent to BD. So we're going to cross that out. Let's see. How about AC and BC? So we're going to draw AC and BC. There you go. Okay, and the same argument that we just made for AD and BD, that makes AC congruent to BC. Okay, so that is an isosceles triangle. So those two sides have to be congruent. Okay, so then that means that DE is congruent to C, is not congruent to CE. Let's see, DE down here, not congruent to CE. Very common mistake that students make is that since CD is a perpendicular bisector of AB, they then just sort of assume that AB is also the perpendicular bisector of CD. But there's nothing that could be said about the length of CD at all, or its constituent parts, because the only condition that line segment has to satisfy is that it has to bisect AB and it has to be perpendicular. That's it. You can make CD as arbitrarily long as you want, upward or downward. So those two segments do not have to be perpendicular. Okay. So this is one length and this is another length. Okay, so that's the answer. If you just wanted the answer to this problem, you could go to the next video, hit the next button. But we also did create an extra problem for you guys to review. So AC is the line of symmetry of quadrilateral ABCD. So that quadrilateral ABCD is a kite, and BD intersects AC at E. Okay, which statement must be true? BE equals AE, AE equals EC, BE equals DE, and AC equals BD. Now, definitely pause the video, try it on your own. If you get the same answer as us, definitely hit that like button. So this is what we do. we look at the diagram, and if we're doing process of elimination, understand that this diagram, in this diagram, AC does look like the line of symmetry of quadrilateral ABCD, because the left side and the right side look symmetric. So any statement that looks to be true, any statement that is obviously false about this diagram, it cannot be true, right? So we're gonna hopefully do that, and maybe it'll get us the right answer. So now BE equals AE doesn't look to be false. AE, so we're saying must be true. AE equals CE, that looks like that is definitely false. So that's not the answer. BE congruent to DE, okay. Ooh, number one, I read it wrong. BE congruent to AE, that looks to be false, so that's not it. And BE congruent to DE, that one looks like it could be true. And then AC congruent to BD, that is it's tough to see, but again, C could be moved down, and that AC would still be the line of symmetry. So that's probably not it. Okay, so that's probably going to be the answer. That's just under visual intuition. Okay, so how do we do this in actuality though? AC is the line of symmetry, so you got to understand that the left side and the right side are symmetric. So that makes AB congruent to AD. That makes BC congruent to DC. AC again is the line of symmetry. And then this segment joining B and D, that segment BE is congruent to that segment DE. Okay, so those are all the symmetries, all the congruences for angles that we can make, and the other congruences that we can make are about these angles. Okay, so those two angles are congruent, the constituent parts are congruent, these two angles are congruent. Let's see, these two angles are congruent. That's congruent to this, and then this is congruent to this. Okay, so those are the statements that can be made about congruence. That's just by the symmetry relation. So in this situation, BE and DE, BE equals DE is one of the choices. So that's what could be said. All the other congruent statements that we just made can also be said about sides and angles. Okay, hopefully you got this. Hopefully this was enough for you to really get going on what a line of symmetry is, what a kite is, and what we can say just from the fact that a line is a line of symmetry. So definitely hit the like button, subscribe, and thanks for watching, and I'll see you in the next video starting right now.